Hello yet again, this is Alex, and you're watching Animate Magic. In the first part, I need to explain what we are doing. So I'm trying to create this effect inspired by a drop of ink being dissolved on paper, basically. So we have this video here, that is the ink drop itself, and this is what we'll try to achieve with this tutorial. I mean, the effect will be different, but if you fiddle with the settings enough, I believe you could get something that is fairly close to this kind of effect. But I just chose to go with something a little wilder and a little more distinct. So that would be that. Yeah, so this is the initial tutorial. This is a footage by Billy Rybka. He is a YouTuber and he made this tutorial about blending videos using this ink drop effect, and I wanted to blend some videos using the ink drop effect, but I just thought that maybe it would be cool to make my own ink drop in Houdini, so I tried to devise this method, and it came out pretty cool, even though the setup is probably needlessly complex. But yeah, here goes. So I hope you enjoy this, and let's do it again. So I will name this second geo in here ink drop again, and we'll start off from scratch with a circle. This circle will serve as a base for our ink drop, and it will be a polygon circle on the axis of ZX. I'll turn off the other effect. Let's give it some more divisions, maybe 200. Why not? It shouldn't be that difficult. You can easily do less if it bothers your system. Let's do an attribute triangle, because we need to set the normals, and this way is the easiest actually. So I will name it set n. I should really do a recipe about this little wrangle, because it's just so handy and it's super easy and super quick. But let's say add normal equals normalize at p. So right here with this thing, instead of having the normals point up, we have the normals point out. And that's good, that's what you want, because I want to do an attribute noise. And noise the position based on the normal. And I don't want to recompute it, I just want these normals. So with this first noise, I'll just try to dial in some basic shape. Let's make it a little smaller. Some basic shape that would actually end up as being the final form of the ink drop geometry, at least. So maybe just some more of this resolution here, and some less, a little less roughness. And yeah, okay, this looks okay. Let's copy this attribute noise, put it here yet again, but I want to make this first one into set, just to be sure. And right now we need to change it, maybe back to 1, maybe even like this. Well, maybe add was actually better. The point is to get some interesting shape. And with the second noise, I will do a add value, but I will add a negative noise, or rather I will set it to be minus 0.8 to 0. So the second noise subtracts from the first noise, basically, from the position of points. So it shrinks it. We are doing this because I want to use this blend value to basically go from fully subtracted to non-subtracted, and that will give us this slight growing. And I like this way because it gives us more growth in this very low deformation area, and goes back to this basically noise pattern that we started with. Okay, so I will just do one. What if I would just delete it and do it like that? I think this is good enough. Let's do a transform. Put it in here. I'll make it quarter of its size because it's just kind of big. And I'll use a size match axis, I think, or match size. Yeah, match size. Just to I can be even before this, just to make it center at all times. See, the difference is very slight, but there is one. So we want this to be at 0. I'll just refer to this quickly. So in here I didn't even use the match size, I can see, but that's okay. Alright, so that is the first part of the geometry setup. Let's finish this off with a null. Put it here, say out geo inc, and I want to bring this node into caps, so I'll go in here it again and create a cap network. We can even make it 4K right off the bat, because why not? Sometimes when you have playback on, you shouldn't be really changing parameters, because that can crash stuff. Let's save it as a new iteration, so I'll just make a new and call it re-recording, and yeah, just save it there as it is. Copnet inc expand geometry. No, first of all we go with SOP import, and we want an external SOP, which will be the geo inc, and we have it. But right now it's just geometry, and we want to rasterize it. But to rasterize it, we also need a rasterize setup. So plug it in here. Very good. Select the z-axis, because I believe this geometry is in y-axis from the top, but I suppose the texture is looking at z-axis as the top in this way. So if we are looking down at our geometry, then that means we need the z-axis for the texture, basically orientation y coordinate. And let's rasterize it. Amazing. It grows ever so slightly. It will not be all that visible after we add the particle effects, but it's slight enough to be there. After this, I want to make this initial okay. After this, I want to make an initial band around the ink. That is this at the very first frame, you can see it. Let's just refer to it one more time. Okay, so this is it. Let's go to first frame. I want to create this band. So I want to enlarge the initial drop, then make the inner drop, envelop it very quickly, and basically make this feathered out look. So to do that, I will drop down a UV map and a streak blur, and I will blur this shape using the UV map, and thanks to this node we have a UV direction of the texture coordinate with 0 at the center. So if we are using this for the streak blur, that means it will blur it outwards from the center, and in this UV space, if you use texture coordinate, then 0 is in this left down corner because it's 0 to 1 and 0 to 1. So that's not what we want, but there is an option for that. So I will stick with this image coordinate and basically just animate this length from, let's say, 0.8 at the very beginning to maybe at frame 14 we'll make it a 0 or 0.05, so it's just very faint. And I want to blur it again, because this streak blur creates some, maybe not in this geometry, but yeah, let's set this bias to 0.3 because it will make it just a little bit bigger. Or maybe let's not do that. Let's leave it at 0 because, or we leave it maybe at minus 0.2. Okay, let's use blur to blur it even further. Point 2 maybe. And right now I want to use this as a second stream, and we'll merge it with the first stream, but in a second. First we need to add fractal noise. I wanted amplitude of 1, centered around 0, and fairly small, supposedly. And let's do a multiply this blur with the noise. and that gives us this very sharp texture. Let's work with the noise so that we get something that we like. It can be pretty small, it could be not that low. Maybe the contrast, or maybe not. 3D noise, sure, but don't animate it. Okay. Roughness. We just want a nice grainy texture in the noise. That's the point of it. So let's just settle for something. And right now let's do a maximum and combine both of these streams. Now let's do here in the background and this in the foreground. Okay. So we have this banding in the first frames, and let's just go back to this noise and make it a little weaker, because I think it's probably doing too much. If you look at the reference image, the drop is basically a sphere. It's not that noisy, but we can always adjust it later if you want to. Okay, so strict blur is a little heavy on our scrolling, but we like it as it is. I like it as it is. So let's go back to the SOP land and continue with our particle effects. So I'll drop down a convert line and change this geometry into a spline, into a polygon line basically, and let's just use one. That's good. Convert line, that's what we want, and let's make it connect path and not compute rest length because we won't be using it. Next off, we are making some noises on it. Let me just refer to it quickly. Alright, let's do attribute noise, and do emission. This will be our custom attribute to drive where do we want a lot of particles and where do we want fewer particles to spawn on the geometry, and we need to create a visualization for it. So you can either press this button and then open this menu and you will find one of these here. It will probably be called something else, and then change it to whatever you'd like. I use color and use the color type as ramped attribute, and the attribute is emission, with the ramp being black body. So when I use this emissions scale here, I get these I get the preview of the noise basically. So let's do this, do some much smaller noise. and some gradient warping or lattice warping with small lattice and nice warp, big warp. You can see how that works on our noise. What I want to achieve is basically kind of rough noise that goes from high highs and low lows. So to get that even more, and this needs to be a float, I will just take this ramp and make the lows low and the highs super high. So it's basically has a high contrast. Okay. Second thing we need is this point velocity, but before we do that, let's just go back to this second noise and make sure we don't recompute the normals. We want the normals pointing outwards. Point velocity. Very good. I want to create this point velocity out of our normals and create visualization again. For this thing, I'm using some funky pink color and a small scale as a vector, this velocity. So basically we want to make it point outwards at all times, but maybe not that outward, but not as curvy as this, so just a little bit of curl. And don't make it animated, but make the swirl size somewhat smaller, so it's just pointing outwards, but it's not that obedient. It's just a little off. Okay, let's follow up with pop network and do some actual simulation stuff. So this popnet right now is going crazy with our velocities that we have. Every point is getting a velocity and they are just flying out infinitely, which is cool. Doesn't look that bad. First of all, in here I want to set up this pop source, so let's use an emission attribute. For starters, right now we can see that it's more random. There are points where there are more points and there are areas with less points. That's good. Let's do birth and make them live 3 seconds instead of 100, so they will actually die at some point and start disappearing. And let's deactivate constant animation and let's just spawn maybe 200 frames for now, 200 points for now, and make them spawn at $FF smaller than 2. So basically only on the first frame. Boom. Boom. Okay. But that's not a lot of particles, right? Like, we need something more. So let's do a pop replicate in here and merge them with the initial. That's a lot of particles. So let's disable constant emission yet again, and this one too. Impulse activation of 1. So we are spawning 1 particle every frame based on the initial particles, and using a point and we don't want to inherit any velocity. So that way, these particles will just create. Okay, what is not working? Shape, don't inherit velocity. Well, let's just do group just born because we will need it. Born, just born. It will be useful in a sec. I wonder why are they not getting spawned. Impulse count is 1. Shape is a point. Their life is alright. Is this velocity thing? Yes, it is. So let's not inherit velocity. And let's make inherited velocity 0. Yeah, so that's what we want, interestingly enough. So right now, these pop replicate points, let's make them trails, and I'll do pop color to make them some curious color. Maybe it will be a pinkish yellowy pastel color for the trails, and white background. Dark background. Okay, so they are expanding like this. Pretty crazy, but not crazy enough for our purpose. And the other particles we will make red, because they are important and they are the leading ones. So every first particle is just red, and it creates a dot every frame for every simulation frame. And while we're at it, if we make more simulation frames, adding substeps, we'll have more dense lines. So for the final simulation, I'll probably use 4, but for now I'll use 2. And let's see how dense it is now. So we can see that these are getting denser, more densely populated lines. So I will want to use these points with the initial points to create lines afterwards in subs, just by like we would be using a trail sub. But because we are using the pop replicate method, we need an attribute that would basically be unique for every single of these points. So we can use an add by group and attribute, and here we will put that attribute. But let's create it first. So let's make a wrangle. It will be pop wrangle, and put it here and there, so it's the same for both of them. Initial attributes, and I will just create I at home equals to I at ID, and we want to do that just for the just born group, just born, because this will ensure that this wrangle basically will only evaluate once when they are just born, and create these attributes that we need, and then every subsequent action that we take in the solver will just inherit all of our attributes from that. And one more attribute that I'd like in here would be a vector at iv for initial velocity, and that will be just a copy of at velocity. And don't forget our semicolons, just like I did, and we have it. Pretty basic, nothing changes for now, but in the add SOP we can now add it and use attribute home to create our lines. And there is a problem with them, but we will solve it in a moment. So the initial setup is ready, basically, for our velocity actions. So let's drop a pop VOP and drive some velocities, drive some more interesting velocity into this. So let's call it val custom, and let's leave the flag at the output because the solver doesn't really want us to put it anywhere else. Alright, and in here we'll do a bunch of things, but first things first, let's create an add node and a anti-aliased flow noise. Alright, so we are using the velocity to the add and position to the noise, and we want this noise to be 4-dimensional so that it's super complex. So let's do vector to vector 4 and put this in this position here and add a frame number to it as its fourth component. So now the color of our inputs and outputs in this have changed, and that is good. That says that our noise is now 4D. Let's make the output 3D and add this output of this noise to velocity, and let's plug velocity to actually output it, and now we'll get some funky velocities. Wow, cool. That's crazy. But it's actually too crazy. For our flat cop purposes, for the ink, we would like the particles to only travel in 2 dimensions. We don't want them going wildly up or down. So to do that, I will just do vector to float and float to vector, and split them like that. Split the velocity and leave the y component disconnected, so our particles will only travel in 2 dimensions, leaving it ever so flat. And that's cool. This noise is pretty crazy and I want some controls on it, so let's ignore that error and minimize the console, and now let's promote the parameters. And roughness, the rest is probably not that important for me for now, and I want to create some controls for this wrangle, so I will make first of all let's just make these controls that we have. So one more thing, multiply multiply parameter timescale. And we can use this parameter to make our frame number be either bigger or smaller, so it will effectively control the speed of our noise. And that's pretty cool. It's still super crazy. Okay. Let's edit parameter interface and make all of these surplus folders invisible, and actually all of the folders invisible. After that, let's put a separator in there, put this timescale at the top, and make a folder, call it AA flow noise, and put our controls in there. Apply and accept. And I want nice controls for these noises, and I already did it before in my setup, so it's super annoying for me to do it again, but I will do it again. So let's make a switch and a parameter. Yeah, it's connected wrong, but we'll fix it in a second. And also a constant. So we want to plug in a constant of 0 and the noise in the second input, and take this parameter, make it a toggle integer, and call it use AAFN flow noise use, and the alias flow noise, yes. And I will use this as the switcher. And in these controls, let's just drag it into the folder with the rest of them, or above it, or inside it. Apply and accept. So right now, if this is unchecked, we are not getting any velocity, and if I check it, the switch will switch and we get the noise patterns. But something broke, because I am inputting this vector, this as a float value, and our noise is being converted to a float value. So I will make this a 0, 0, 0 but vector, and this will work. Very good. But one noise is just not crazy enough, so let's make another noise, and it will be a curl noise. And it can also be controlled by these four-dimensional value of our position plus time. So let's do this, and let's make the same switcher for it. I'll just call it use curl, use curl noise, and add it in there, and add it in here. Alright, and just promote some of its parameters, because we'll be also wanting to control this. All of these are probably overkill. Let's make also the attenuation and turbulence, just for the sake of completeness, and create another folder. edit parameter interface and make a folder, call it coral noise, drop all of this inside, just a coral noise, toggle, and apply and accept. And one more thing before we do that, we don't want these folders to be tabs. I'd like them to be just simple. Apply, accept. Although that's probably personal preference. We could do collapsible, we could do simple, we could do tabs. It's all good. We just want to control our noises in one place. Alright, so we have two noises, and if I do both of them, then it's probably going to be super crazy. And it is. Which is somewhat good, but actually not that good, so let's do time scale of 1. Let's see what this fourth component can do. So now our noises are not only crazy, but they are also animated and getting even crazier. And at the frame 72, all of our particles are just dying, and they at the same time all of them just stop generating more points. Okay. Let us continue. We have these attributes and we have this, but for quality of life of my particles, I would like to do something different. So we have the life in here. Let's drag it out and do fit. So right now it goes from 0 to 3. Every particle gets, basically right now this is just 3. And that's okay. But I would like to randomize that value. Let's do random, base it on ID, do a float output, and multiply it with this. Yeah, this is how it goes sometimes with these wires. Okay, and then put it into, we don't have live in here, so I'll just create bind export and export it as live. Live, super nice. And it's still a float, very good. So right now every particle gets a value, and right now let's maybe leave it like it as it is, and pop live. So right now some of them are leaving super short and some of them are leaving super long, basically because this is a totally random value and we are between 0 to 1, and we are multiplying the initial age with the 0 to 1 value, and this is what we get. But I'm using this fit to get some more control over this value. So now that I think of it, maybe I should fit this value even before. Let's see what it does. If I would fit this value between 0 to 3 or even 0 to $RF end divided by 24 frames. So if I change this length, this is 24. Yeah, wait, this is too fancy. Let's just do 3. I'll use that expression in another time, soon enough. And the destination max, let's go 0 to 1 and see what happens. Okay, so now they die super quickly. Now let's skip it. It's better this way. What I want in here is bind, and I want the emission attribute. Do you remember emission attribute? We established it all the way back in here, and it basically is a random, semi-random value of most of our points, and we are driving the emission by this emission. And I would like to take this emission attribute and multiply it by a parameter. Let's do emi mult emission multiplier and yes, emission, no, multiply it by this. Put it in the original multiply. Now put it in the fit, but in the destination max. And multiply it by 3. Because that noise goes from 0 to 1, or from -1 to 1. So let's maybe, to make sure, also do an absolute value here, so that it's only positive. Alright. 1. How about that? So right now some of our particles are living absurdly long time, and some are living super short. And that's bad. We want to control how long they are living. So what could I do to improve that? I am going a little bit off script here, so bear with me. I will try and think of something. So first of all, let's change this. Let's do, I'll just promote both of these. Yeah, that's even better right off the bat. 0 to 3. Emission multiplier I can delete, because this emission, we'll do it different way, differently. Why don't you work? For real, why don't you work? Yeah. It sometimes looks as if they are going forward and backwards, but they are really only traveling along 2 axes. Okay, so these values are getting multiplied by a random. So, and then getting fit. This would probably be 3. Because if this will return to 1, then it will be just the same 3 that it got. And now we can do, for example, minimum life to be 0.7 and maximum life to be 1. So now they will live roughly the same amount of time. Or I could do max of 5 and min of 0. So they will the difference in their life can be big, basically. Okay, for this effect, I want the maximum life to be not that big. I don't want them to travel very far, but also not like this. And I would like them also to slow down as they age. So let's do that in this velocity setup. So let's do a ramp. Let's take the age. And fit it. So this is where I want to make this expression, that $RF end by divided by 24, because our age is a number in seconds from the beginning until the end. It is a value of 4 in here, and it is a value of 0 in the beginning. And if I want to use a ramp, I need a range of 0 to 1, so this fit does exactly that. And let's use a ramp. It works somewhat wonky sometimes. This ramp, this will be age ramp. A spline ramp and inverted default, and in here we will get a ramp. I want it to be at the beginning of the timeline. I want it to be big, and then as it goes down I want them to slow down, maybe not to 0, maybe to like 0.5. And for now it doesn't do anything. I want to multiply yet again. Multiply this by the ramp. And then output this. Okay. Let's see. Yeah, so as they are getting older, they are also getting slower. Let's also do this one thing that I remember right now. Bind export, because I want to see. And let's do some test attribute. Or let's call it nlife. Because there was also this trick that you could do a divide and divide age by life, or the other way around. I think it was age by life. And this, I always forget what it does, that's why I make this attribute. So let's see this, and let's open our geometry spreadsheet. It's hidden in here under pop object, geometry, and we have it. Let's look for the nlife, hide all attributes, just show me the nlife. So it goes from 0 to 8. From 0 to like a lot. How is that possible? What if I would reverse this? to 30. Let's not bother with this. Okay, we have age. So as they're getting older, they're also getting slower, which is good. And just for good measure, let's make another switch and a constant of 1 this time, because there is a multiply there. Let's copy this toggle, use age, usage, use age ramp. So if I disable the use age, it will just output 1, and all of the particles are getting random and they are not slowing down. If I turn this on, wait, yeah, other way around. This and this. So I turn this off, they're all getting a 1. If I turn this on, this ramp is controlling, is slowing down older particles, even if they're living a long time. Okay, this is actually pretty much it, but I want to do just one more super fancy thing to ensure this setup will do what I want it to do, which is grow outwards. I want the tendrils to grow ever so outwards. And we will ensure that they are growing outwards. Let's just make some more organization here. So I will select all of this, put it down, save it maybe. Let's take all of this, make a box, call it age, and this is all of this. Let's also select it with control or noise val, noise velocity, and this is just the implementation, the end of it. So basically the only problem that is left to solve is this. If I do some more particles, let's say maybe like 500, because I want more particles, everybody wants more particles. I don't really think that these tendrils can grow outwards. Yeah, let's change our noises to make this even more prominent. So let's maybe do the curl noise some more curly. Frequency of the flow noise more frequenty. Yeah, so basically all of these points can go whichever way, and I want them to grow outwards. I want them to grow from this initial dot point basically outwards with some minor amplitude changes, with some random, maybe going left, maybe going right with the noise. But what I don't want them to do is turn around basically, and this is what I will use this initial velocity for. So let's go around and do it. I will do bind and do IV, and just make sure this is Correct, because I was debugging last setup because I misspelled initial velocity. This is why I called it IV this time around. So we have IV. So this is the initial velocity where it started off. This, and it, conveniently enough, points outward. So to create this fancy setup of particles not going back, I will use a dot product. What a dot product does is it looks at two vectors. In this case it will be our current velocity that is noised and crazy, and the initial velocity, and basically says, okay, if these two vectors are the same, if they are pointing in the same direction, and they should probably be normalized, but I think it will work. So let's do this and IV. So if they are the same, it will return 1. If they are completely opposite, it will return -1. And if they are perpendicular to each other, it will return a 0. So this is exactly what I need, actually. So I want to check if this new velocity is either 1 or a 0. If it's below that, then I want to do something with it. So let's do a compare. And this. And this is pretty much it. Let's do less than. So I'm checking if this is less than 0. If it is not, then that's okay, because it basically says that it points somewhere outward. But if it is, it means that the new velocity turned it around towards the initial dot. So I want to do an if block. And in here, let's do add an output, call it val. I will drop this velocity in here and this condition in here. So if you turned your ship around and you want to go back, what I want you to do is blend, not blend transform, I want to blend, no, it was called mix. I want to mix this vector, output this, and maybe do like 0.7 or so, and put in here this initial velocity. Back, like this. So we are checking whether or not it turned its ship around, and if it did, we are mixing into this velocity our initial velocity, which points outwards, more or less, and thanks to that we are essentially making them go only outwards. Let's see, this doesn't work for some reason. I think it should, so let's do maybe a reset simulation and let's give it some substeps while we're here. Boom. Something is wrong. What is wrong? This is wrong. Obviously I need to delete this output. One input, one output, blend it. I want this to be in velocity in, not the next in. Yeah, that's right. So now they should be no longer turning back. I wonder what is happening here. Let's maybe make this blend bias value. Ah, okay, you can see the wires. Wires. I put it in the wrong place, so let's do it like this. That's better. That's much better actually. And as we can see, they are no longer going back. They're only going forward. No matter what I do with the noise, I can do some crazy values in here, and it will still only go forward. Yeah, but this is... and also, now that I think of it, what I'd like to do is create this overall limit for the particle speed. So, to do that, I will do pop speed limit, a handy little node, put it here at the very end, and say that the maximum speed limit is 0.6. So now, no matter how crazy my noise gets, they will never ever go over 0.6 in their speed, which is pretty nice. They're like growing these crazy structures because of the crazy noises. Let's maybe go to back to 1 in the first noise. So like, oh, this one is disabled, is it? Let's see, use curl noise. It's 0, okay, so we are not even using the curl noise yet. If I add this, then it will probably, yeah. And it's still turned a bit, so that's how powerful curl noise is, I suppose. So let's do this 0.03. Just a little bit of curl noise, because I think it's super strong. And I will do this noise to be rather big. Yes, like this. Okay. And rather low roughness. I think that's looking kind of good. Maybe this live could be a little different, but let's leave it for now. We are going to do yet another strand of particles in a second. This is working super nice. This is working good. I would like to add a curl noise to it. Let's say 0.1, and add this curl noise to it, and let's see what happens. Okay, let's see this frequency. Let's maybe do some random offsets. And this frequency to be 20. What will happen then? And I'm leaving the fourth one at 1 because this is time offset, and it will basically make it much more crazy in the time scale, which I don't think I want. Maybe even make it less, because this noise actually changes a lot over time. This is why it gets well, I still can't really wrap around my head around these noises sometimes. But I think this is looking pretty good. Okay. So let's do this maybe also at 0.1. Pretty nice roots or something. Okay, so to make this effect drive it even more home, let's make this less crazy. Let's just 4 by 4 by 4. And maybe this will be just somewhat more. Oh yeah, super nice. What if I would disable the flow noise? Now we are just viewing the curl noise. So it's pretty crazy. Let's do frequency of 4. And the amplitude of 1. Yeah. Let's just preview the lines it makes. Wow, the lines are super faint. There's like super. Oh, this is somewhat bad. Oh, I'll think about fixing that later if it ends up to be a problem. Okay, I would like this to be less crazy. It can be broken, alright, but not that broken. Disable the curl, turn on the flow. And this one we want to be rather big and smooth. Here let's just do 1 or 0.5. So this one could be, what if I would do 4 in the amplitude? And that's probably overkill. Let's do 1 and enable both of them. Okay, so as I mentioned, I want yet another stream of particles to make this even more complicated. But before we do that, let's drive this effect back home and import these lines into cops. So drop a null, put it in here, write out particles or tendrils, and combine both of these effects in caps. So in here I will enter caps, I will copy the setup for the geometry import, and here I will say import tendrils. Cool. And maybe just add it for now to see how it looks together. This will be foreground, this will be a background. Boom. That's way too crazy. And we are still at very low resolution. But that's probably okay for now. Let's don't do add, let's do a maximum. This will make it super blendy. Right now, to make this even more, I could either blur it, but I kind of like the details, so I will probably be deviating off the initial plan to get a ink effect. We'll just get like ink inspired effect, but maybe we can do an add or something here and make connect all of both of them. And so we getting actually a glow effect. Super interesting. And put it maybe there. And this is still a max. This should also probably be a maximum. So this gets blurred, and this then it gets blended in. So let's also, after blur, do a remap, and I will remap the input maximum values to take some more, and probably add some noise to it in a sec. And the tendrils are going way too far. That's also one thing. Let's save and let's go back and let's enable this to be 4K. 4K. And we'll see how it looks. This is kind of interesting. It's not really inky too much, but I don't think that's a problem. I spent a lot of time trying to get this ink feeling of this effect in. So much so I kind of thought, well, maybe without the ink it would be better. So let's try do more particles. 5,000 is probably going to be overkill, so let's go for 2,000. Because we need to remember that these particles are leading, but then each one of these is spawning a particle in here. So that's a lot of particles. Even though initially we just get 2,000, then after a while they are basically getting super crowded. Boom. Nice. I still think they are going too far. They're going too far, these particles. So that is going out like this. Pretty solid. With this remap effect, maybe I could do this instead of this. Is this the same? Probably. Okay, let's continue and add the third particle stream. So what I want to do is create another pop replicate, but this one will work a little different. And I want these new particles to use this, so I will merge them in here and here, please. And I will need to set this attribute, set the attribute home on them separately. So let's do just that. And this pop replicate, the second one, will be doing a separate home, because if we don't do that, we will not be able to later on. This thing goes in here. The pop replicate needs to get some noise. Yeah, why not? I want only one, or let's say 3 particles here, and 0 in here. And I would like this to spawn 3 particles, let's say every 8 frames or so. Let's see if it works. It probably won't. Let's do a sphere this time, but a super small one. Alright, this is way too crazy. Something's not proper yet. Maybe life expectancy shorter. Ah, okay, $sign $FF% 9 equals 0. That's the way to do it. So I want every 9th frame to spawn particles. Nope, still not working. 0. No, it is working. Well, to illustrate this point a little better, I will do pop color and put a color in here, make them red. So this will be the leading particles. And then the strands, I will make maybe violet, but very faint. And in here, this last part, I will do them yellow or something like that. So I will be able to see what is going on. Okay. So the particles are going, and then every 9th frame they are spawning their own particles, and they are leaving for 1 second and then drawing their own lines, which is super crazy and super nice. Okay. Let's see the lines. And then let's see how it looks in cops. The sweep node probably does some crazy stuff with the normals here. So yes, that's certainly not great. Yeah, I think I know what's going on. Because these particles, they are creating the home, but they don't really get the just born group. Still not working. Let's change this to be another one. I'll do delete and make them both union, so they just union with each other, and do a start point and an end point. And see if this makes any difference. Probably won't, but maybe it will. Okay, back to lower point count. Oh, wait. Should it be like this, maybe? Yeah, okay, this fixed it. So now they are getting home properly. And now the sweep node should also look much better, and therefore the cop should also look much better. Okay, let's add some noise to the remapped version. So I'll multiply this and then do fractal noise, maybe the regular one. Add it in there. Do something like this, like this, like this. Maybe change the order of operations. First add the noise, and then I will remap so that it grows a little bit. Like that, you can see. Let's go with this somewhat further, maybe 0.7. 1. See how it looks here. Okay. This is pretty much the effect. I know this doesn't really work. This doesn't really look like the ink effect I showed you in the beginning, but if we fiddle with these parameters enough, it will. But there's one thing that I want to do before we wrap this up is to create a basically iterative blur here in cops, so that it blurs it and grows every time for as many times as we want to invoke the compile block. So I'll do compile block, yes, this block. I'll just add this and say this is maybe color or something, and adds a mono value for both of these, and then invoke. I'll be invoking this and add some color and output also color with mono for both of them, and yeah, So this invoke block will basically perform whatever I put in here this many times, the iteration number many times. I don't know if I need to wire it in like here, but I will. Let's do a blur, or maybe a distort, or a streak blur. Let's do a distort. I haven't used a distort yet. Source it and output it in here. And to distort it, I'll create a fractal noise 3D, output a UV value, slap it there, make it maybe more like that. And do this value strong. And this is going like this because I would like to do this. Maybe the fractal noise normal one, and output UV. But why does it? Oh, I remember. I need to make it zero centered if I want to do it around the 0 point. So this needs to be 0. Boom. And it makes these super nice patterns. But the problem with this is that it's super strong right now, and we are going to be iterating on it, so every time it will do it again and again and again, and it will basically kill itself. So let's do this distortion by 0.5 maybe, so like this. And then this pixel by step gave me nice result, so I'll do maybe 70, and this maybe a 500. This creates this very nice values. So we went from this, or like from this, when we have noise values and the actual values. I could probably do one distortion for the effect and another distortion for the noise in the background, and that would also be pretty nice. Let's maybe make this a little smaller, and a little noisier. In this way. And for the invoke block, yeah, so this distorts it nicely. Maybe this one should be smaller. Ooh. As you can see, this effect can get pretty wild. So, and we have to remember that this will get iterated over and over and over. I mean, I could do this over and over and over, or animate this value, but I noticed that with animated input, this creates this visible like skipping, so maybe that's not ideal. Let's do also maybe a remap here, and just do low values up just a tiny bit. And this step is also getting performed every step, so yeah, it basically grows. And I'll perform it like maybe 3 times and just see what's going on. Use this distortion. Maybe I can maximum and combine our input with this to have yet another layer of this noise, of this stuff going on in here. And now it really starts to grow. Okay, so this is this nice growing effect. I will be wrapping this up with this for now. This is all I wanted to show for this part, which was how to use this invoke block, which I learned from a tutorial from this guy Inside the Mind. He has very nice Houdini tutorials, and it's super useful stuff. And Copernicus in general is just blowing my mind every time I use it. I'm just so happy that I have it in Houdini. So yes, that's amazing. And this pop tendrils with this custom behavior here was also something that I wanted to do in this tutorial. And how to composite it all into this effect. Yeah, we could keep blurring and like mixing these effects, and this would get more and more like, because I like these details. I noticed that if I blur it too much, then it maybe looks a little more like ink, but maybe this is even better than ink. So yeah, I like this, and this is it. Let's just do one more thing. That would be dropping a vinyl. Of course, I know what I wanted to do. And we still at the stage that we have white stuff on black background, so we need to drop an invert node. That would make it black on white. And this is also interesting, so I'll drop it in there and say this is out alpha, because this is basically an alpha map that I wanted to do to blend videos. So wrap image output, save it. Let's do no, I want this cop path. I want to change the aliases variables to copy this into job, but I want it there. Close it, save it, pay out, render, ink outrender ink, and this will be at job render underscore test maybe, and then ink expand $os not this cool. Do I need this as an EXR? Probably not for now, so I'll just export this as a PNG. I just want a black and white value that is nice and lightweight, so I can preview it quickly and see if there is something I like about it or I don't. So let's leave it as a PNG. Export it to C, and this is all. Do a frame range. Oh, let's do test and then V0. Render the disk. And we'll get this effect rendered into nice images, I suppose. And just preview this last thing. Wow, it went really crazy. I think I should cut on the life of the longest tendrils, but maybe not. Maybe this is actually looking good enough. So let's do test render 0 and then expand and see how it goes. Yes, so I'd still like to dial it in. I like how it begins. So at the very beginning we have a lot of particles, and that's looking amazing. But then this life cuts down on too much of the other tendrils, and only these long ones stay. So I would probably change that to make it more inky without this super long tentacles basically. But it's still pretty dope, I think. It's looking pretty nice. It's looking even better than what I achieved with the first iteration of this effect. So yeah. If you are here watching, then thank you. I hope you learned something, and I'll see you next time. Alexander out.